Hello, I am Lucie Robert, a junior at Kennett High School. This fall, I was part of an ongoing study at Tin Mountain Conservation Center in Albany, New Hampshire. Last summer, I set out to learn more about climate change in our local community and environment. 2 mornings a week, I joined Tin Mountain research scientists in their ongoing data collection project. The data I helped collect this fall is part of a long-term collection project focused on counting the species and abundance of birds within the Tin Mountain property in Albany. Each morning at dawn, we completed point counts in which you walk to a series of exact points and stand for 10 minutes to keep track of all birds heard or seen during that time. After experiencing the collection of data, I was ready to begin using it to answer some questions. Based on the point counts and my research into New Hampshire Audubon Society's data about birds, I was drawn to 3 particular species. A few years ago, New Hampshire Audubon published models predicting how temperature increases will impact vulnerable species in New Hampshire. They used past data and temperature predictions to do so. The Audubon Society has used data to predict the effects of temperature rise on bird populations if our average temperatures rise 1.5, 2, and 3 degrees Celsius. These models and the Tin Mountain data inspired me to further examine the American robins, purple finches, and blue-headed vireos. First came the exploration of the American robin, a very abundant species on the Tin Mountain property and a species considered to be at risk by New Hampshire Audubon due to climate change. The 2 major concerns for this species are spring heat waves and wildfires. These wildfires lead to the destruction of food sources and habitats. These are both weather events that northern New Hampshire has experienced an increase in recent years and decades. As you see on this map, they have started to and will continue to lose much of the southern end of their summer territory as these events become more frequent, and we will see them moving farther north. The purple finch is the state bird of New Hampshire, so naturally I was interested in the abundance of this beautiful species over time. Spring heat waves and heavy rainfall are 2 of the major threats to purple finches, as both of these events endanger young birds in the nest. This results in a lower survival rate and therefore a shrinking species. Just like the American robin, they are losing the southern end of their summer range as they move farther north to avoid these weather events. The third species I researched and analyzed was the blue-headed vireo. This bird is considered to be at high risk of the effects of climate change in our area. This is due to both spring heat waves that put young birds at risk and urbanization that destroys their habitats. The blue-headed vireo is also a bird that migrates later in the spring and fall, so I had a personal interest in the effects of changing local temperatures on their migration patterns. Before diving into analysis of the data on these 3 birds, I researched what is known about temperature changes in our region. The University of New Hampshire conducted a study of the maximum and minimum temperatures from 1895 to 2012 in northern New Hampshire. As you can see in these graphs, though the temperatures fluctuate throughout the years, there's an increase in maximum and minimum temperatures over time. With these temperature increases in mind, I organized the data that we collected at Tin Mountain. I began by exploring the correlation between temperature and the abundance of American robins on the Tin Mountain property. In order to do this, I began organizing the data in Excel, looking at the abundance in each season. After organizing the data, I dove into statistical analysis for the first time in my life. I relied heavily on the researchers at Tin Mountain to help me lose a little bit less of my sanity as I learned about statistics. With the American robins, I used a tool to look at the correlation between temperature and abundance. Correlation is a negative 1-to-1 scale, in which any number above 0.70 in either direction indicates a correlation in the data. As you can see on this data table, when I ran correlations in all seasons, there was neither a positive nor negative relationship present. This means that in our Tin Mountain data, there is not a correlation between temperature and abundance of American robins during this time. The second bird I focused on was the purple finch. It turned out that we did not have consistent enough data on this species to draw conclusions about abundance. This stresses the importance of the work researchers are doing in collecting climate data consistently over long periods of time. The third species I analyzed was the blue-headed vireo. I originally questioned if there was a change in their durations of stay, meaning, was there a variation in the date they first arrived on the Tin Mountain point counts in the spring to the last day they were seen in the fall? To do this, I used Julian dates, which, as you can see in the table to the right, assigns a number to each date in the year, making it easier to compare dates year to year and throughout data. After finding the dates of the blue-headed vireo arrival and departure, I was able to analyze if their length of stay had changed. I did this by running an ANOVA factor, or an analysis of variance. This is a tool that determines if there is a significant variance between data groups. As shown in this table, the ANOVA gives you many pieces of information. However, my focus was on the p-value, or the probability value. When this value is 0.05 or lower, it indicates that there is a 5% or less chance that what we are measuring is random. This means that we could conclude that a relationship exists. In this case, our results showed that the length of stay of the vireo had increased. However, because the time period I was looking at was only 4 years, I didn't feel like I could conclude that the effects of climate change were occurring. So I ran a correlation with temperature. I did not find a correlation between temperature and blue-headed vireo length of stay. Therefore, I found that there was not a significant conclusion about the impact of climate change to be drawn from this blue-headed vireo data. When I set out to complete this study, I knew that I was not going to find the world-changing cure to climate change, or even proof that climate change was happening within our local species. And you may ask why. Climate change is something that we know is taking place, but must be understood by looking at decades and even centuries of data. This project allowed me to experience the data collection and analysis, but I then turned to other scientist data to better understand what is happening to our birds statewide and nationally. To do this, I used research of the New Hampshire Audubon Society. As I referenced earlier, the Audubon Society has used past temperatures and bird activity to predict the threats that species will experience as the temperature in our environment increases in intervals of 1.5, 2, and 3 degrees Celsius. These temperature increments were used based on models of the future. 1.5 was chosen because that is the increase in our environmental temperature that is imminent if we do not take immediate action. It has also been predicted that at our current rate, we will experience 2-degree increases by 2050 and 3 degrees by 2080. On this visual, each temperature increase is represented by a mountain. The numbers in red show the number of species that are considered by the Audubon Society to be high vulnerability. The orange numbers represent those rated at moderate vulnerability, and yellow represents low vulnerability. As you can see, as we climb towards the increase of 3 degrees Celsius, we see a rise in the number of species at risk and a decrease in the number of species that are considered to be healthy. I know what I have shared sounds like all bad news, but I don't wish to leave you with a feeling of helplessness. I would like you to leave empowered. We as humans can impact these temperature changes. The UNH study that I previously discussed was able to make predictions about future temperature increases. They based this on 2 models of emissions that humans cause. As you can see in both the maximum and minimum temperature graphs, there is a red graph that shows how the temperature will increase with higher emissions, and a blue graph that represents the situation where lower emissions occur. In both of these scenarios, the maximum and minimum temperature is rising. However, in the model with less human emissions, the blue graph, the temperature rises less drastically. This means that if we can reduce our emissions in the coming decades, the temperature will rise less and bird species here in New Hampshire will be impacted less significantly. But how can we do that, you ask? In order to make a difference in lowering temperature change and other threats to our local birds, we each have a role to play and an ability to impact change. I have broken down actions we can take into 3 categories: daily habits that we can strive for, ongoing commitments to think about annually and throughout our lives, and long-term goals that will require our time and patience. You can see in this chart actions to take in each of these categories. You may already integrate many of these into your daily life. However, to protect our local species, we are all going to have to commit to more of these habits and encourage those in our communities to do the same. I will leave you with this. I took this photo on the summit of Mount Pierce and Crawford Notch a few weeks ago. Upon summiting, I entered the utopia that many of us experience living in this valley. Standing on these peaks and looking at these views makes it hard to grasp the impacts of climate change. But it is happening. It's happening here. We must stop to look at the data and take the required steps to prevent negative impacts on our habitats. It is through these actions that we and our local species can continue to live in this utopic environment. Thank you for engaging in this discussion with me and for taking actions to protect our local and global species.